At Okane, we understand that the relationship between mining and water is complex and closely intertwined. Mining depends on water for processing, refining, and transporting product, but it can also be significantly impacted by water. For example, too much water accumulating behind dams can pose geotechnical stability risks. On the other hand, not enough water at a site or an inability to secure sufficient water can pose processing challenges. As it relates to closure and post-closure long-term liabilities, water is also critical because it is the primary mean of transporting deleterious substances off-site. In Okane's experience, the long-term liabilities post-closure are primarily related to water. This highlights how a water stewardship approach is critical for the mining industry. Sustainable water management practices must be integrated at every phase of the mine lifecycle, from the early design stages to mine closure and relinquishment. The risks and costs associated with water management can extend well beyond the active life of a mine, making it essential to plan for closure early. At Okane, our approach to water stewardship supports clients in addressing water management challenges. Through our water modeling capabilities, we develop models that are powerful tools to inform water management planning and decision-making. We also provide detailed design services for water conveyance and storage infrastructure. Let's look at a practical example where one of our clients asked us for support with reviewing the closure performance and updating the closure plan of a mine site located in Scandinavia. The goal of the project was to ensure that any water quality impacts from a potentially acid-generating mine rock facility were mitigated. As part of an overall closure assessment, a study was conducted to understand the long-term water quality of the basal seepage from the mine rock facility. In collaboration with other consultants, Okane helped evaluate the volumes and water quality of both runoff and basal seepage coming out of that facility. We used various numerical and analytical modeling techniques to assess the long-term potential of their mine rock storage facility to generate acid rock drainage. We developed numerical models to estimate the facility's long-term oxygen ingress and net percolation rates based on inputs gathered from 10 years of in-situ cover system monitoring and field testing. Our numerical models guided the design of the engineered cover system for the facility. The cover system was designed to limit oxygen ingress and reduce the acidity loading. The stored acidity that is being flushed out would benefit from the neutralization occurring within the facility. Our model results confirmed that the design would function as intended and indicated that during post-closure, the water quality would gradually improve, thus confirming that the engineered cover system would perform as intended and significantly reduce the overall catchment acidity loads. For this project, we used advanced tools and modeling capabilities to represent complex systems, assess water management scenarios, identify source control and water quality mitigation options, and inform decisions on closure and water management planning. Our goal is to provide our clients with tailored solutions that maintain project value, achieve successful closure outcomes, minimize environmental impacts, and promote responsible mining practices.